All right, so we're taking a look here at question number one. A car has an oil drip. As the car moves, it drips oil at a regular rate, leaving the trail of spots on the road. Okay, so which one of the following shows a car continuously slowing down? All right, so when you think about speed, all right, so we know average speed is distance over time. Okay, so in order for someone to be going slower, just thinking about this in a common sense way, in order for someone to be going slower, basically they're going to cover less distance, right? If I'm running somewhere versus walking, if I'm walking or if I'm running, I'll be able to cover a lot more distance running in the same amount of time if I run for 5 seconds versus if I'm walking for 5 seconds, I'm going to go much, much less distance. Um, Either that or I'd have to go for a longer time to cover the same distance. So basically, if it's slowing down, we're looking for a distance that is decreasing. So if we got a oil drop, drop, happening, drop at a regular interval, all right, and the car is moving as it makes these drops. There's my awesome car. Okay, but the car starts to slow down. Well, the drops are going to get less distance between them. If the car stops, we're just going to get a giant puddle because it's just hitting the same spot over and over. So we're looking for, as we slow down, to have less distance between the same amount of time. So the only one that matches that is A, where we have a distance between the dots that is decreasing, showing that it is slowing down. You could see the dots getting closer and closer. Slower it goes, the closer the dots would be. All right. And here's another one. Here's another one involving a car, I guess. So number two, motion of a car is graphed. We have velocity versus time. Always important to look at your axis and see if this is distance or a velocity graph. This is velocity versus time. So we know this represents a constant velocity of 20 meters per second. And then we see the velocity decreasing all the way down until it gets to a velocity of 0 where it stops. So constant velocity, then decrease in velocity, constant deceleration there. How far did the car move during the first 15 seconds? How far? Okay, so if we look at the graph, our first 15 seconds is this part right here. First 15 seconds. So we're not going to worry about that part where it goes down. The math gets a little tricky there. But for this constant speed, we can easily solve for how far being distance. So we would take our equation that has distance, time, and speed in it, which is the first one on your formula sheet. Average speed is distance over change in time. And we need to set it up for distance. So if we make a formula triangle, remember when it's the division one, what goes in the top stays in the top. And then time would be down here and speed would be over here. So to find distance, cover it up, it's speed multiplied by time. And since it had a constant speed of 20 meters per second, so this would be 20 here for my speed, multiplied by the time of 15 seconds, first 15 seconds. So we multiply that by 15, and you should get, I believe, 300 meters, 20 times 15. So that's the first two questions on this.